Alright, so we now looked at how to create a straight line equation. Now we're going to look at parallel and perpendicular lines. So if I have a straight line equation like this, a parallel line is a line which has the same gradient. So something like this red line would be parallel to the blue line because they have the same gradient. So two parallel lines will never meet because they have the same gradient and they'll go up at the same steepness all the time. So the way we know if two lines are parallel or not is when the m values are the same. So the gradient values are the same. So in the previous video, we looked at how to find the gradients. If the gradient values are the same for each one, then we know that there are parallel lines. Right, so these are parallel lines. There's also something called a perpendicular line. And a perpendicular line is when the line is at 90 degrees to another line. So if two lines are 90 degrees to each other, then we call it a perpendicular line, like this. Okay, so the way we show that if it's a perpendicular line is also with the gradient. So let's say this gradient of the blue one is MA, okay? And the gradient of the green one is MB. The way they're related is actually MA times MB has to be equal to -1. So if we multiply the two gradients together and it's -1, then we know it's a perpendicular line. Sometimes you might see it as MA is equal to -1 over MB. It's just a rearranging of this formula here. But the same theory stands, that the gradients multiplied together will give you -1. And that's the difference between perpendicular and parallel and how you differentiate between each one. And there'll be certain questions we'd ask you to find parallel lines or perpendicular lines relative to another line which they've given you before. Let's take a look at this question here. So we have a line, it's parallel to the line 3x plus 6y plus 11 is 0, and its intercept on the y-axis is 0, 7. Write down an equation of this line. So first thing says, we know that the two lines are parallel to each other, meaning the gradients are the same. So we need to find the gradient. What you should notice is the way they've written out the straight line equation is not in the general form of y is mx plus c. Okay, so you can't say that this 3 is the gradient straight away. That's going to be incorrect. Okay, so make sure you rearrange it in the form y is mx plus c, and then you can find the gradient and the y-intercept. So rearranging it, so we have 6y is equal to minus 3x plus 11. Dividing everything by 6, we get -1 over 2x plus 11. Now we've got it in the general form of y is mx plus c. Now we can work out the gradient. So the gradient is going to be -1 over 2. So the gradient of the first line is -1 over 2, meaning the second line is also -1 over 2 because they are parallel. So we know this line is going to be y is equal to -1 over 2x plus c. We just need to find the c value, and they said that it crosses at 0, 7, so we just plug it in. So, or, because it crosses here, this c will be the y-intercept is 7, right? So y is equal to -1 over 2x plus 7, like this. Let's try a perpendicular line equation. So we have an equation of the line that passes through the point 3, 4 and is perpendicular to the line 4x minus 6y plus 7. So find this equation of the line. So once again, we need to know the gradient first as always, but we only know the gradient of one line, but we know that they're perpendicular, so we can find the gradient of the second line. So once again, we have to rearrange this in the general form of y is mx plus c first, just to find the gradient. So we get 4x plus 7 is 6y. Y is equal to 2 over 3x plus 7 over 6. So the gradient of the first line, m, is going to be, I'm going to call it ma, is 2 over 3. But the second line is perpendicular to this first one, right? So if I call that mb, then we know that mb is -1 over ma, just rearranging it. So the gradient of the second line, the perpendicular line, will be -1 over 2 over 3, which will be equal to -3 over 2, like this. So therefore, the perpendicular line we can say is y is 3 over 2, or -3 over 2 x plus c. And now we find the c by plugging in this 3, 4, plus it passes 3, 4. So 4 is equal to -3 over 2 times 3 plus c. 4 is -9 over 2 plus c. C is therefore 17 over 2, so we can say y is equal to -3 over 2x plus 17 over 2, like so. Okay, so as long as you make it into the general form y is mx plus c, find the correct gradient, use the correct gradient whether it's parallel or perpendicular, then we can find all these different types of lines.